dear students. Welcome back to this another video where we will be discussing IIT JAM Economics 2025 paper. There are a couple of other videos for the solutions. In this series, we are discussing the paper of IIT JAM Economics of 2025. There are other videos where I have discussed the earlier questions from the section of MCQ. And in this video, we are continuing with the discussion of MCQ, which is question 16, question 20, and question 21. All these three questions are coming from the direct conceptual side, but with a little twist, and hence they become very important to be discussed here. So let's get into the video and learn about these concepts. Question number 16. It is about which one of the following statements is correct. So 4 statements are given to you and you're being asked that which statement is correct. So higher the cash reserve ratio, smaller the money multiplier. Higher the cash reserve ratio, larger the money multiplier. So in these two statements, there is a relationship between the cash reserve ratio and money multiplier. So what is a cash reserve ratio? As you all know, cash reserve ratio means that how much cash a commercial bank, when they receive deposits, how much they can keep with themselves, how much they have to keep with themselves, so that the remaining money can be lent out to the borrower, somebody who is visiting the bank for borrowing money. So if you're receiving, let's say CRR is 20%, just hypothetical example, it means out of the 100 rupees you're receiving, 20 rupees you have to keep with yourself as a bank in reserve, in cash form, in liquid form, and only 80 rupees you can lend out to the person who is coming for borrowing. So that is CRR. So the first two options are quoting a relationship between CRR and money multiplier, MM. So either one of them can be true, not both. Similarly, if bank holds all deposits as reserve, larger the money multiplier. So eventually here they are saying that CRR is 100. So larger is the money multiplier. Again, the relationship is between CRR and money multiplier. Cash reserve ratio does not influence the money multiplier. Again, the relationship is between CRR and MM. So you can see all these two, only B and C are going in same direction. That is, higher CRR means larger money multiplier. But the other three are going in the opposite direction. How to choose the correct one? So the first thing is, what is the formula for money multiplier? So money multiplier in the economy is equal to 1 upon CRR. 1 upon CRR. We are not considering, there are other, I am repeating, there are other parameters in the money multiplier such as ERR, but I'm not considering it at the moment because we have to study the relationship between CRR and money multiplier. Now you can see that they have an inverse relationship. If CRR is going to increase, money multiplier is going to fall. If CRR is going to fall, money multiplier is going to increase. Or in very simple words, if CRR is going to be a large value, money multiplier will be smaller. And if CRR is going to be a smaller value, money multiplier will be higher. Now, why is this the case? If we check economic theory, is it supporting? Yes. So what happens is, if the CRR is higher, that means commercial banks have to maintain a high reserve of deposits with them. And hence, as a result, they can only lend out lesser money. So when the CRR is higher, money lending is going to decrease. So eventually the money you are lending out to the people is decreasing. Now, if the money lending decreases, what will eventually happen? The money which was getting lended, it was leading to credit creation because that was ultimately being used to generate more income, more output. So eventually lesser money is lended and hence lesser money will be created, and then the bank will receive in turn less deposits. So eventually higher CRR means less money being lent out, then lesser deposit, and eventually smaller will be the money multiplier. So credit creation process is going to fall down there. And as a result, what will be my correct answer? My correct answer will be Higher the cash reserve ratio, smaller the money multiplier. So option A is my correct option because this is going inverse. That higher the CRR, larger the money multiplier. Completely wrong. C is completely wrong. Cash reserve ratio do influence money multiplier. You can see it is coming in the formula. So this is how you can break down the solution of question number 16. I hope it's clear. Now you can also have a look at this detailed description of your money multiplier and the same which I have mentioned here. All right. Now, next to this, let's talk about question number 20. So question 20 is, consider a firm that produces a single good using labor and capital. Let C, Q, L, K, W, R, and P denote cost of production, level of output, labor, capital, wage rate, price of capital, price of output, respectively. So, cost of production is given by C, level of output given by Q, labor given by L, capital given by K, wage rate given by W, price of capital given by R, and price of output given by small p. An example of the cost function for this firm is. Now, this question is little tricky. Do you know why? Very simple thing. First, they're asking you cost function, which is a very simple thing, right? They have just briefed you about the firm and haven't mentioned anything here. So, as soon as a student sees such type of questions, they start analyzing the options. So as a student, if I will also analyze, I will see C is equal to WL plus RK, okay. Minimize WL RK, okay. C is PQ divided by WL plus RK, okay. C is equal to Q into 2 under root RW, okay. So I will say, oh, this is just a simple firm. So cost function is eventually okay, WL plus RK. So I will go with this. But this is wrong. I tell you why this is wrong. They are asking you cost function, and cost function have always to be given in the optimized terms. The cost function needs to be in terms of your output, in terms of your cost of factors of production, the input factor prices, which means here L and K does not have. This is a simple cost function. Only when I will optimize this cost function, I'm going to get the actual cost function of the firm. Right? So, how to proceed? Now, in such scenarios, the first thing is this is a firm which is using all of these resources. So, the availability of all these factors which are given to us, Q, C, L, K, W, R, P, these hint toward the presence of Cobb-Douglas production function. Cobb-Douglas production function. So how do we write a Cobb-Douglas production function? It is given by Q equals to A, L raised to the power alpha, K raised to the power beta, where alpha and beta can take their own values. So the most, now when in such questions, the production functions are not given, or Cobb-Douglas production function ki form is not given, you have to take the standard form. Also, one very important thing to note here is the min function won't come here, so you can rule out this option. Now, out of 3 options, I have to see that which one will be suited. This is not an optimized one, so I will rule this out as well. Here also L and K is coming, so I will rule out. If you have studied the optimization without even solving, you can go with D option. You will say because only this cost function is optimized, so I should go with this because every other option has L and K. And in optimize, the optimized cost function is a function of W, R, and Q. These 3 things. But if you don't know the smart guess working technique here, you have to solve this. So if you take the standard form of Cobb-Douglas, the standard form of Cobb-Douglas function is Q equals to L raised to the power half, K raised to the power half. Now I will use this production function to find my cost function. So let's start this. Let's start with this. Now, let's solve it. So, first of all, I have taken my Q equals to L raised to the power half, K raised to the power half function. Now, where do we achieve equilibrium for a Cobb-Douglas production function? When we do Lagrange method, or even if I write the equilibrium condition directly, equilibrium is achieved where marginal productivity of labor with respect to marginal productivity of capital, the ratio of MPL and MPK is equal to the ratio of the price of these factors of production. So labor is being paid W and K, capital is being paid R, that is the rent over here. So I have to solve this. So on a side note, I'm solving for the value of MPL. MPL is the derivative of Q, partial derivative of Q with respect to L. So that would be half L raised to the power minus half, K raised to the power half. Likewise, MPK, marginal productivity of capital, del Q by del K, that is half L raised to the power half, K raised to the power minus half. Now, when I solve them, when I do the ratio, I'm solving it here so that I can have mess-free calculation. So when I solve them here, I would get half and half cancelled out. Minus 1 by 2 and minus 1 by 2 will give me L minus 1. 1 by 2 and minus of minus 1 by 2 will give me 1 by 2 plus 1 by 2. So that will be 1. So I got the answer as K by L. So I can write it here. K by L equals to W by R. From here, I will try to substitute the value of 1 back into my production function. So K, I'm writing in terms of L. So that is W by R into L. So that is equation 1, you can consider it. Now I'm going to substitute this value of K back into my production function. So Q is L half and K half, which is W by R into L raised to the power half. Solving this, I would get L half W by R raised to the power 1 by 2 and L half. L half and L half together becomes W by R raised to the power half and L. So this is the value of Q I'm getting. From here, what am I going to get? From here, I will get the value as L equals to Q into W. Half means under root. So under root R upon under root W. So this is the optimized value of L, the labor. Okay, this is the optimized value of L. Now, if I put this L value back into my equation 1, I'm going to get optimized value of K. So I would get W by R into L, which is Q under root R divided by under root W. So this will give me Q, W and W will cancel here. So under root W, under root R and R will cancel. So under root R I'm going to get. So this is the optimized value of K. Now I've got optimized value of L and optimized value of K. Okay, so I will take them ahead. Okay, so I'm writing L star equals to Q and under root R divided by under root W, whereas K star is equal to Q under root W divided by under root R. This is what I can write as. Now I need to find the optimized cost function. Always remember the cost function is WL plus RK. So WL, I'm just going to substitute the value of L as well as the value of K. Now, if I solve this, I should get my Q, and what I can do here is these are going to cancel out. So this will be under root W. Likewise, this will be under root R. So I'm going to get Q as common, and this would give me under root RW together, under root plus RW together. So cost function at optimized is Q twice of under root RW, which is my option D, which is suiting my option D. And hence option D will be my correct answer. Option D will be my correct answer. All right. So option D is your correct answer. So option D will be my correct answer. Okay. So this was the solution to question number 20. Now let's move forward to question number 21. So question number 21 reads, consider a consumer with utility function given by y plus under root x, where x and y are quantity of two commodities consumed. Which one of the following is true? Again, whenever you have to read that which one of the following is true, you have to analyze all the options. Income elasticity of demand for both goods is 1. So for both of the goods, the income elasticity is 1. Income elasticity of demand for good X is 0, for good Y is 0, for good X 0.5 and good Y is 1. In other words, we have to find income elasticity of X and Y. How can you find income elasticity of X and Y? Now, income elasticity means first I need to find the optimal value of X as well as optimal value of Y. So for finding the optimal value of X and optimal value of Y, I first need to find the optimization. So I will be using the Lagrange method. Now, utility always have to be maximized subject to budget constraint. So that would be Pxx plus Pyy equals to M. This is my budget constraint. So my Lagrange would be utility function, that is my objective function, plus lambda M minus. This is how we substitute your budget constraint into the Lagrange. Now, the first thing is I will be doing, I'm just doing it here. I will be doing the partial derivative with x, put it equal to 0 to get some values. This will give me 1 upon 2 root x plus lambda, and over here I'm going to get minus price of x equals to 0. Now this gives me lambda price of x is equal to 1 upon 2 root x. I can consider this as equation 1. When I do partial derivative with respect to y, put it 0, I am going to get 1 plus lambda minus py equals to 0. This gives me lambda py equals to 1. Now equation number 2. I would divide equation 1 with equation 2. This will give me a relationship between x and y. So lambda px divided by lambda py. I'm dividing the left hand sides. Right hand side go if I divide. 1 upon 2 root x divided by 1. Now lambda and lambda cancels out and I get the ratio of px and py, which is 1 upon 2 root x. Now this is some sort of relationship I have got. Now I will take this ahead to get the value of x eventually. From this equation, I am going to write, from here, I am going to write, we got px upon py equals to 1 upon 2 under root x. Now this will give me under root x equals to py upon 2px, and this further gives me x equals to py square and 4px square. Okay, this is what it is going to give me. Now I will substitute this value of x into my budget constraint so that I get the optimized value. That is how we do. Now the budget constraint is px into x plus py into y equals to m. So I just have to substitute this value and solve the budget constraint. Now, solving this will give me px cancels here. So what am I going to get from here is p square y upon 4px plus py into y equals to m. From here, I would get py into y is equal to m minus p square y upon 4px, and this would give me y equals to m upon py minus p square y upon 4px. That is what I'm going to get. Now py, if it comes here and divide, it will cancel the square power. So py ko I have brought in the denominator of this term. So m by py. Likewise, p square will get divided with py, and I am going to left with only py over here. Okay. Now this is the value of your y. This is the value of your y. Okay. Have a look here now. So I have got the value of x, I have got the value of y. So the optimal values of x and y should be in terms of prices and income. Now this is optimal value of x, this is optimal value of y. One very important thing to notice here is x is free from m. M is my income. It is free from m. So what will be the elasticity of x with respect to income? elasticity of consumption of X, demand of X with income elasticity, which we call, will be zero. Very simply, because it is independent of income. But when I have to calculate it for Y, the calculation will go like this. Elasticity of Y with respect to M is del Y upon del M into M upon Y. So del Y upon del M is the derivative of Y with respect to income. That would be 1 upon Py. Whereas I am going to put the value of Y back. This would be M upon Py minus Py upon 4Px. Now Py, if it gets multiplied here, it will get cancelled. So M upon Py into M upon Py. Py cancel. So M minus Py, when it gets multiplied with the second term, it will be P square Y upon 4Px. Now, what is the value of what will be the value of this elasticity is something we have to opt, because MCQ is giving us some options. Now see one thing, the entire answer will depend on this expression, that is P square Y upon 4Px. Always remember, P square Y upon 4Px will be less than income, because P square Y is the square of the price of Y. 4Px is the 4 times price of X. This is the price ratio. So it will be less than that. Also, if you will notice down one thing, the value of X is something similar. If you just remove the square from here, that is the value of X. So this is the value even lesser than the X over here. So it will be less than M. So M will be greater here. Eventually, if it is less than M, you are subtracting a term from M. So M upon something, this term cannot be 0. This term will be closer to 1. Because if you go with options, the options are reading closer to 1, 0, and this thing. So I have to either choose between. If you go back to your question, the question reads, for Y I'm saying, because for X I know elasticity of income is 0, but for Y it was 0 or it was 1. So I have to choose one of them. Now if you let's say confused, you are not sure. If we talk about the case that you're not sure that what is the elasticity of Y over here as well. If you're not sure about elasticity of Y over here, you can see that this is the expression I'm getting. So will it be equal to 0? Never, because M cannot be 0. But when can it be closer to 1? When this term is very small than M, and M minus this is nothing but it is equal to M. So something is equal to 0 basically. Okay. So if this term is closer to 0, then M upon M will be closer to 1 over here. So according to that, if you try and analyze, the option D will be completely wrong, because X income elasticity is 0. So it's not supporting. For both of the goods one, this option is also incorrect. For Y, I can sure it is not 0. So eventually option B will be my correct option, that income elasticity of demand for good X is equal to 0. And this is the solution for question number 21. I hope this video will help you analyze your solutions, as well as it will help you understand concepts by solving these numerical questions. All right. So we will be coming with more such videos. So subscribe to our channel, and it will help you to get updates from our end whenever we are going to post another video for the solutions. So thank you for watching this video. If you like it, please share it with your friends as well. And do let us know in the comment box that what are you willing to watch in the IIT JAM 2025 series next. You can also tell us if you want solutions for some particular questions. And one more thing for your information, that on our app, on the Ecoholics app, you can get access to strategy PDFs. You can get access to free study material PDFs, as well as the segregated PYQs for IIT JAM till 25. So you can download the app and can subscribe to a lot of study material available for IIT JAM purposes for free. Thank you for watching.